It is quite evident that over the years, computing and computers have evolved drastically. However, there are several issues that have continued to affect the human race that the traditional computers, which we have today, just can't do. And some of these things include climate change, which scientists have been battling for quite some time, and the extra computational resources needed by chemists in the laboratory. However, with the newly introduced form of computing called quantum computing hitting the market, none of these have to be viewed as obstacles any longer. Now it is only right that you may wonder what exactly these quantum computers are, how they work, and what the future holds for these computers. Well, to get answers to these questions, then you are at the right stop. Welcome to Prometheus Network. In today's video, we will be explaining all there is to know about quantum computers. For a fact, that name sure sounds extravagant. However, these quantum computers aren't so hard to define. These computers are basically machines that make use of certain properties of quantum physics for storing data and properly performing computations. Just like the classic or rather traditional computers, quantum computers perform similar tasks. However, certain things differ, and these differences give quantum computers an upper hand, making them more powerful than traditional computers. With traditional computers, you have a computer that stores data in binary bits of zeros and ones, but on the other hand, with quantum computers, you have a computer that works with quantum bits, or better known as qubits, as its basic memory unit. Now that we know the unit of memory these computers make use of, it is important to know what these qubits are. Basically, these qubits were created with physical systems, such as the spin of an electron or the arrangement of a photon. All of these systems can be arranged quite differently at the same time, and this property can be referred to as quantum superposition. Even more, you are given the liberty of linking qubits together with a process called quantum entanglement. This therefore results in a series of qubits that can simultaneously represent several things. An excellent way to make sense of all of these is to properly compare them to a traditional computer. Now, for a traditional computer, 8 bits is quite sufficient to represent numbers between 0 and 255. However, on the quantum side of things, 8 qubits is sufficient for the quantum computer to simultaneously represent each number between 0 and 255. But here is the big question. Even while we have been able to establish that quantum computers are for sure faster than traditional computers, we still need to answer the why and the how. Now, so you can easily understand how this works, take, for example, think of the average supercomputer that just may execute a complex task, such as sorting through a huge database of protein sequences. However, we have to admit that these traditional computers have a weakness that has to do with seeing the simple patterns in the data that several scientists use in determining the behavior of those proteins. Now, these supercomputers only end up faltering. The fact remains that traditional computers can, in fact, just may attempt folding a protein with an insane amount of force while actively relying on the many processes involved in checking every possible way the chemical chain may bend before an answer is provided. But as this protein sequence continues to get a lot longer and more complex than the traditional computer can handle, it becomes a problem as the regular supercomputer begins to stall. A chain of about 100 amino acids folding in several trillion ways certainly can't be achieved with a traditional computer. However, quantum algorithms, on the other hand, have taken an entirely new outlook on all these kinds of complex issues as it designs multi-dimensional space where the patterns link individual data points. So still with the protein folding example, this pattern may be the blend of folds that requires very little energy to easily produce such a combination of folds, and that simply serves as the simple solution to the problem. It's really that simple. The traditional computers we've always known simply can't create these sorts of computational spaces, and so as you would expect, finding these patterns may be a lot harder for it. But with quantum computers, all of these prove to be very easy as they are basically built for the purpose of solving all of these complex problems. And to solve all of these complex problems, the quantum algorithm creates a multi-dimensional space where you have the patterns linking individual data points surfaces. Now, with all of these performance features and amount of calculations, you would expect that such a machine would in fact consume more energy than anyone could imagine. However, the case is actually otherwise. When we look at quantum computers, we see machines that are actually quite smaller, hence requiring less energy. The sizes may be, however, relative, considering the quantum hardware designed by IBM could somewhat be the same size as a car, since most of its space is taken up by the cooling system that is very much needed so the machine can maintain the superconducting processor at an ultra-cold operational temperature. And unlike the initial quantum computers, the more recent computers make use of what is referred to as qubit entanglement to aid the computation power of the computer linearly. This is simply how it deconstructs. In the early time, Albert Einstein had a theory that quantum particles formed correlations with each other in a way that the quantum state of a particle, like its spin direction, could easily be determined by simply observing another particle, regardless of how far apart they may be. Einstein went on to call this spooky action at a distance, and of course made up his mind that there had to be something not right when it came to quantum mechanics. But on the contrary, there actually wasn't anything wrong. Based on a set of experiments, it was discovered that these sorts of interrelationships, in fact, exist in nature and became the heart of quantum mechanics. And so is entanglement, as it is an integral part of quantum computers too. This combination is what makes quantum computers as powerful as they are. This entanglement is also used as a computational multiplier for qubits. Now, aside from all of these, there are very important issues that scientists are after solving with these quantum computers. And at the top of that list is an issue that has been a huge problem in our world today: the global warming. This is, in fact, considered the worst thing caused by we humans that could happen to the planet, and is already. However, with quantum computers, we are able to welcome a brand new weapon in the struggle to save the environment. For this, however, to be successful, there is a need to completely understand in detail all of the atomic level forces that are at work when certain molecules form a bond with other molecules, or even when they split. And knowing all of these things, we can be a step further in providing a means to invent even newer processes and materials that could be of huge benefit. However, the restriction with even the largest and fastest computers is that they simply do not have what it takes: the ability to replicate atomic-level quantum interactions. And even with Moore's law, reaching these capabilities in 1,000 years is still not guaranteed. But thankfully, there is a solution, and this solution is quantum computers, and within the next decade, we can have computers with this ability. Computers that make use of quantum states of atoms to replicate the quantum forces of nature. And as for helping with global warming, quantum computers will go a long way in helping the development of carbon capture and also certain storage technologies. This development as well will certainly lead to the discovery of brand new techniques for carbon capture, leading to an improvement in our ability to pull out carbon straight from the air. As it stands, there simply are no cheap or easily accessible catalysts for carbon capture, as these are usually very precious metals. But once this CO2 is successfully captured, it can further be used in the production of concrete, metals, and plastic. These quantum computers will heavily feature in the evolution of batteries, as batteries are becoming much of a priority, with the world gradually moving away from all that has to do with fossil-based fuels. However, it is important to keep in mind that batteries do rely on a long cycle of experiments and, to an extent, computational simulation. Nonetheless, all of these can be achieved with quantum computing as scientists reach the level of comfortably simulating all elements of the battery chemistry under virtual experimentation at the atomic level. It doesn't end there, because even the food we all consume will be affected by quantum computers and their abilities, as they will be very much implemented in the production of fertilizers, which in fact is quite a role to play. In the real scope of things, we have fertilizers that contain nitrogen that make use of a certain catalyst that takes up about 3 to 5% of the world's natural gas, which costs about $300 billion every year, only accounting for almost 2% of the yearly worldwide CO2 emissions, while on the other hand, we have nature creating nitrates for free with no forms of emission. This on its own is now a topic scientists have decided to take up and put a lot more focus on to understand and simulate the required processes. However, to achieve this, there is a need for the introduction of quantum computing. With quantum computers, there will be full support in the creation of new catalysts that will be needed in the production of energy-structured fertilizers, while bringing about a rather exceptional cut in carbon emissions. In fact, according to the Boston Consulting Group, while traditional computers would take an insanely long period of over 100,000 years to properly model the molecules that would replace the already existing chemicals, quantum computers would do a much better job by requiring just 1 day. Crazy, isn't it? Finally, we all know that hydrogen remains one of the cleanest fuels, as it only produces water. Nonetheless, affordably producing hydrogen can actually be a problem, considering the fact that the efficiency of the processes involved is always between 70 to 80%. And most of these problems stem from how complex water can be when it's in its liquid state. However, who said there wasn't a way around it? Once again, with the help of quantum computers, there can indeed be a huge development of more efficient new hydrogen production methods that will help in the electrolysis process simulation. This will indeed be a huge step for mankind. Life will be made easier and a lot faster. Do let us know in the comments section below your thoughts on the quantum computer. Also, remember to subscribe if you are new to the channel and hit the notification bell for more content like this. Till next time, thank you very much for watching.